Hey everyone, so time to keep good on my word in the microphone video and give you guys another Thingomatic update. So let's dive in. So first things first with it, I've been able to make some significant changes since the last video. I finally got my custom extruder installed and the E3D V6 mount created, and all that is sitting in the printer, and it actually works pretty well. The only drawback right now is the fact that I'm running a threaded rod to add tension to the system. I'm still figuring out how to hook up a spring, but that's near and coming. Now to dive into more of the recent updates, I've been working on trying to actually use the printer and was starting to run into problems with the Z-axis wobbling a lot like this when it was traveling. So what I did is I came along and I super glued up all the wood, which was good, but then had an unintended consequence. The problem was, the reason why it was wobbling a lot, you could say, is because these microscopic little bronze bushings were jamming. Now, to give you guys an idea, the ones in my Ultimaker 2, which is right behind my head and my crazy hair that you can't see, 3 of the bushings stacked on top of each other is the length of the bronze bushings that it uses, while the ones that the Thingomatic uses are a lot smaller. So the problem is a lot more load is being placed in one extremely tiny area instead of being spread out. Now, I'm not fully sure why they did this. If Bree or whoever helped design this thing wants to explain it, I'd love to hear it. Barring that happening, what I've decided to do on the Z-axis is make bushings that run the whole length of the Z-axis assembly, if you will. And that's about, I think, 1.5 inches, 1.75 inches long. It's a lot longer than the bronze bushings that it had originally. So the advantage of that is the fact that the load will be spread out over a much larger area. So to prototype it, I whipped up some simple bushings, the design in Fusion 360, then I sent it over to my Ultimaker 2 and 3D printed them out in PLA. Now, that's probably not the best choice, as PLA does have a pretty high coefficient of friction. I was thinking maybe a ton of PTFE grease, this super lube stuff would work. Didn't really do the trick. So I'm now looking into either using, I guess, bearing material, filament, my bad, or if I'm going to actually try and machine my own bushings from Delrin AF, which for you non-machinists is Delrin plastic, which is a pretty slick material with Teflon added to increase the surface, reducing the surface friction and making it smoother to run. So I might or might not go that route. If I were to custom machine them, it's not an impossible thing to do, it's just it's somewhat time consuming. If I was going to do that, I might as well look into replacing all the bushings. So we'll see. The advantage of the 3D printed ones is 3D print it, ream it out, job done. So hey, we'll see. You never know. I'm still trying to figure it all out though, if you will. Another big change that I made to the machine is I added some custom 3D printed components to it. These were printed on my Ultimaker 2, but they're pretty simple. One of them is a little support for the Y-axis idler bearing for the belt, as originally this was literally just screwed into a chunk of acrylic and had a tendency to do this, or even crack the acrylic, both of which are not good. So what this does is it holds it on the top, helps spread the load out, and makes the system a lot more stable. Another modification I did is I found some plates on Thingiverse that you can drop a nut into and screw down over the motor mounts for the X and the Y axis, and using an external screw it allows you to draw tension on those externally. It saves you a whole bunch of work on the printer trying to work on loosening things, retightening things. It really, really helps. So that's where I'm at now. Yes, the printer is functional. It can do prints. It's just it tends to jam up a lot on the Z-axis, and that's pretty problematic, my bad. The main issue is the fact that the wood at the top is somewhat flexible, so it'll compress or expand like that when it should be putting all the power into moving the head up and down, which is really annoying. It takes about 1 millimeter of travel before anything happens, and this is a real problem on the first layers, as the nozzle's literally like smashed against the print as it's trying to force things out. And if the extruder doesn't jam, usually one of the axes will skip. It's not a pretty situation all around. So besides making some better Z-axis bushings and potentially all around, I'm going to work on also designing up a simple plate that goes on the top that goes between the 2 Z-axis rod cover mounting points and bolts to the Z-axis stepper motor, so that way it acts like a much stronger simple reinforcement without having to go drilling a bunch of holes in the printer or doing anything crazy. Really, its sole purpose is just there to help take up the load and make things a bit more sturdy, if you will. Pretty simple, but it might make a big difference. Regardless of putting the newer bushings on there, I'm still going to do that because I feel like that is a slight problem point on the printer and it would probably greatly benefit from it. So as for the bushings on the rest of the machine, I'm not sure if I'm going to keep those bronze bushings or not. The main issue with them is the fact that they are designed to be used in applications where they get warm enough from friction that they literally sweat out oil that is in the bronze, which is a porous type of bronze, so it has room for the oil to shrink into when it is cold, and it sweats it out when it is hot. The problem is on the printer, I'm not going over 30 millimeters a second in a rapid move, so it's never in any of its motions ever going to get warm enough to start sweating oil out on its own. So it's pretty much relying on whatever lubrication is on the rods, and that's not the best way to be doing things. I mean, I'll occasionally put some 3-in-1 oil on there, but it's still not the best solution. So that's why I'm debating switching over all the bronze bushings or just keeping them there and remembering to oil them. Not fully sure yet. I am trying to keep the machine relatively stock, but I will say that after working a lot with at least really short bronze bushings, they're definitely not the best choice. I mean, the Ultimaker 2 uses them, but like I said, they're a lot longer, so the load on them is spread out a lot more evenly, and also there's a lot less weight on it. So I'm still figuring that out, and we'll see where that goes. That said though, one positive thing is in all my testing, I've been able to use this. It's my slightly nozzle too close because of the Z-axis issues melted my build tack slightly flex plate, but besides all that, this thing is amazing. And some footage that sadly got lost on a crappy SD card, I actually showed myself flexing a print off of here, and it is amazing. So huge shout out to Kayla over at BuildTack for sending me this over. It is awesome. When I actually get the printer running and get it going, or decide to get one for the Ultimaker 2, I will definitely do an in-depth review on this, but I figured now that I finally used it, I had to finally give BuildTack a nice thank you for that. So I hope you guys enjoyed this episode of Make It with Calvin, and I hope it wasn't too technically intensive for you non-machinist, mechanical engineer types out there. If you guys have any questions, please feel free to leave them in the comments down below. Also, feel free to subscribe to my Instagram. It is at Make It with Calvin, which is the official Instagram of the YouTube show. I'll be posting up some more updates, giving you guys some sneak peeks of things coming up, all that good stuff. So I will hopefully see you next time here on Make It with Calvin, working on the Thingomatic, doing all kinds of awesome stuff. See you guys later.